So what if it's all but darkness from where the ends of our universe reach? The thought of our universe continuing for all of eternity, bound to never have an end. Or does it? A cold, lifeless and motionless void filled with darkness and loneliness. To think that's what lies at the end of our universe. Does the universe have an end? If it does, how did science prove the universe has one? And when or where does it end? The discovery of the deep black void that lay outside our planet created a baffling mystery of what could be out there and beyond. As time and humanity progressed, technology was reinvented over and over until it reached heights that enabled mankind to explore outside our realm and beyond. With today's advanced technology, humans have been able to study the deep darkness twinkling with stars more accurately, with much more precise measurements and estimates. Discoveries revealed the most intriguing things about the beauty beyond our skies, like the discovery that shooting stars were actually meteoroids being propelled through space above our atmosphere. That the world was following a sequence of cosmic explosions and convergence, all thanks to gravity, and so much more was revealed to mankind. But while it answered the majority of our questions, it created even more. Now, many all over the world ask the same question repeatedly. How big is our universe? That question had already been debated since the discovery of our universe as far back as 100 years ago. In the early 90s, Harlow Shapley and Herbert Curtis, two well-praised geniuses of their time, had argued on this very question at the Smithsonian Institution Natural History Museum. Their debates brought forward were merely of personal evaluation of the solar system and in an attempt to convince the others that they believed the universe existed that way. Curtis brought forward his theory of the universe existing as a combination of several individual smaller universes. His theory proposed that the nebula was a distant system of stars far beyond our Milky Way. In opposition, Shapley's theory proposed that the spiraling nebula were rather not but gas floating freely around the Milky Way, which would be summed up to make what we know as our universe. In counter to Shapley's theory, Curtis would then argue that our Sun was positioned close to the center of our galaxy. Taking into consideration the mostly accepted basis for what and how our solar system exists, one can definitely see how both Curtis and Shapley were both right and wrong with their theories. As for Shapley's, his theory failed at evaluating the size of our universe, but was more accurate as to where our Sun was positioned. In Curtis's defense, his theory was far more accurate at explaining the size of our universe, but failed rather at determining where our Sun was positioned. Now push forward to a more modern time where technology has progressed a little farther. In 1996, the debated topic was once again taken up by a unique group of researchers who had a much better understanding of the universe. Gustav Tarman and Sidney van den Berg argued the topic while using the Hubble constant as a means to drive the size of which the universe had gotten. If you didn't know, the Hubble constant is an astronomical term referencing the unit of measurements used to measure and describe the expansion of the universe. Tarman argued that the Hubble constant for the universe was of a pretty low value of 55 kms to 34 MIS. But Sidney van den Berg used proof to assert his beliefs of the values being a lot higher at 80 kms to 49 MIS. Despite Sidney's values being larger, it would rather determine the universe as we know it to be a lot smaller and younger than we knew. As explained by science, the Big Bang acted as a Kickstarter to which the universe was born and continues to expand. And as it expands, it's estimated to increase in speed. Both Sidney and Gustav's theories were accompanied by workings to which they tried to convince the other side, but ultimately failed at swaying the other or the astronomers who joined in on the argument. Even as time progressed till the present age with tech advancement, astronomers and scientists still find it hard to conclude the perfect calculations of Hubble's constant. Some figures have been put forward, but these are mostly just in theory as mathematical terms and remain unproven. Still, with how advanced the technology of today has become, scientists have been able to discover machinery known as satellites that helps them detect galaxies and solar systems 13 billion light-years away. It's through this research that they've been able to calculate and measure most values about how the universe is expanding, when, and how fast. Did you know that there wasn't one Big Bang? Ultimately, the Big Bang theory seems to work more perfectly when applied to the physics of the world. That said, a lot of scientists and science space enthusiasts have concluded that the Big Bang didn't occur in one play, but multiple of them, and is in a continuous loop where it occurs once every trillion years. If this theory holds any truth to it, it proposes a system of the universe lapped against and after each other, meaning our universe could be infinite, or rather have an end for an exact number of calculated times, before experiencing another Big Bang and spontaneously increasing again in size. Science does a great job at explaining the flow of life, but for the most part there isn't any proof as to how big our universe is, and if it has an end. There are, though, empirical formulas and theories built on the study of the universe. But that's just what they are. Taking into consideration the formulas of our ever-increasing universe, many have asked the question, can we measure how far our universe stretches? If we take a look at Andromeda through a telescope capable of seeing far into space, the closest galaxy to the Milky Way, you would be surprised to realize that what you are looking at is not what Andromeda actually looks like today, but rather what it looked like years before. It's known that light, although the fastest recorded, has its limits and would take a certain amount of time to travel from a point to another based on the length between them. Now, taking into consideration the length between Andromeda and Earth, it would take 2 million years and more for the light released by Andromeda to travel through space to Earth. This, currently, what we would be seeing now, is a reflection from years ago. The same theory is applied to other gas and light giant formations. Whatever you would be looking at is but the leftover reflection. Through this knowledge, scientists tried looking for more answers left behind by giant galaxies, and eventually they came across a leftover glow from the Big Bang. Also through this research, it was revealed that our universe is perfectly linear and uniform. Most parts of the universe were thicker compared to others, but were all aligned in a disk shape as distant light converted or converged. All in all, the galaxy appeared to be flattened. Based on this discovery, the measurements using mathematical theoretical formula revealed that a finite universe would be 200 times bigger than what we were able to see. If you didn't understand that, you can expect the universe to stretch 11 trillion light-years from all directions. Does that make the universe infinite? Well, not really, as it does have an end, unless you are to consider the theory of Big Bangs occurring over and over in trillions of years. Then its infinity would depend on how many times a new Big Bang occurred. And measuring such a universe would definitely have no end. Other than that, you've got 1 trillion light-years worth of universe to explore, one with an end. After taking a look into all this information about the universe, you probably have an idea or two about what could lie at the edges of our universe. Taking a look into theories that explain the birth of life, it's made known that the Big Bang started creation, and later on it was theorized that not just one but many in infinite spots. And before that, what did science have to say? Well, it's believed in science that before the Big Bang there were energy inflations that were inherent specifically to the Earth itself, and for these Big Bangs to have had such an impact as they did, the energy used to create them would have to be massive enough to create the solar system and all of its components, as we know. In our modern world, these questions to what lies at the end of our universe seem unanswered, or rather, the only answer humans have ever been given to the mystery of what lies at the edges of time are mostly in theory, and for the most part without proof. Though science has been right countless times, it's not beyond mistakes as well, and for humans to know what really lies at the end of your universe, if there is one, they would have to have had the answers to 3 questions. Before the Big Bang that led to creation, how big was space and how long did it stretch? If energy inflations are essential to creating Big Bangs, how much more of it is left out there? And before our Big Bang, how long did the energy inflations need to go on for, and how much of it was needed? As of now, if we are to conclude on the final evaluation based on all the information we've got about Big Bangs, we can only conclude that our universe does have an end. But that doesn't mean it can't increase any further or expand. It would just need the right component or chain reactions for it to expand. And since humans aren't responsible for the creation of life and stars in the first place, then it's safe to say that creation can carry on naturally on its own, with or without the interference of human civilization.